This is where I stopped part 1 of the series, and if you haven't watched it yet, it gives you a solid advantage for what I'm about to test. All folders are closed, and I'll begin with a quick sneak peek into part 3, where I walk you through the documentation of this project. The README is a high-level overview of my testing strategy. I use Minitest for all model, controller, and integration tests, and Capybara for system tests. I've written dedicated guidelines for each type, and I use FactoryBot for setting up test data. If you look at the folder and file structure, the auth/flash folder handles sign in out. The model/folder contains a concern/slash/error subfolder. The system/tests have a dedicated stimulus/folder for component testing. The test helpers/folder includes 7 helpers that help simplify my tests. A little advertisement here. These docs are actually a reduced version of another project called Candy, while this one is named Randy, as in Rails and Andy. Candy stands for Cursor and Andy, a conceptual framework where I collaborate with AI teammates to work on user stories, generate code, and maintain documentation. I call it the Stoff 5-pillar architecture. So, the naming conventions you see in Randy actually come from Candy and made their way into this documentation. All my models follow a specific structure, which I'll show you in a moment, and my model tests reflect that structure too. If I add, say, an enum to chat later, AI or I will know exactly how to name the corresponding test. Same idea applies to my controller tests. For integration tests, I add flow to the file name. For me, these tests act as a bridge to system tests. And system tests can be tricky. I learned that the hard way. Smile. So I recorded a screencast of my failures and my solution. The standard way of running system tests with bin Rails test system needed to be changed. Now I run each test file on its own using a find command. Why? Because otherwise system tests with headless Chrome fail. I still believe it's related to the dialog element used in my drawer. A screencast on failing headless Chrome tests is a bit niche, but if you're curious, give it a try. All right, enough documentation. Back to the code. I'm starting with the sessions controller tests. Now, guiding you through tests can get a bit boring, so I might skip some of the more repetitive ones. If a test isn't readable, if it's not clear what it's doing or asserting, then I've probably done something wrong. Grin. In the required test helper, I've added my test helpers/folder to the load path, included my authentication helper, chat helper, FactoryBot, and a slow down helper that's a little more intentional than just using sleep. Anyway, with FactoryBot in place, I create a user and reuse it across tests. I check whether redirects work as expected and whether the correct flash alerts are shown. The tests mirror the actions from the sessions controller. A nice, simple pattern. The first test in the dashboard controller test covers our protected route path. I log the user in and out using the helper methods from authentication helper. Assert, and done. That leaves us with the chats controller test. This one is meant for high-level or miscellaneous tests for the controller. For example, I only test whether the chat's index action is protected. Testing every route for authentication feels like too much overhead. Might be overkill, but maybe you have a comment on that? Now on to the tests in the chat/folder. I mentioned my naming conventions before, so let's start with indextest.rb. I test whether the chat index page renders with the correct turbo frames and ARIA attributes, whether the user sees the hint when there are no chats, and when there are chats. Though here, for some reason, I don't use FactoryBot. Can't remember why. Maybe you can relate. There's also an I18N check, and we verify the presence of the logout link. Let's take a look at showtest.rb. This one's pretty straightforward. In the setup block, I create a user, a chat that belongs to that user, and log in. The first test checks whether the chat details page renders correctly. We call getChatURL at chat, expect a successful response, and check that the chat name appears in the response body. We assert the presence of an H1 with the correct name, a div.container, and an SVG. That's our copy button. The second test is about authorization. We create another user and a chat that belongs to them. Then we log in as our original user, try to access that other user's chat, and expect a redirect back to the chats list. We also assert that the correct flash alert appears. In this case, authorization.denied. Clean, readable. Now let's destroy chats. Same setup as before. We create a user, a chat, and log in. I'll skip the usual authentication checks. We've covered that already. The first test deletes a chat via plain HTML. We use assert difference to confirm the chat count decreases by 1 and check that we're redirected to the chats list with a flash notice. The next one's more interesting, destroying a chat via TurboStream. Again, we assert the chat count drops by 1, but this time we also check the TurboStream response. The chat item should be removed from the DOM, and the flash messages area should be updated. There's also a quick format check to make sure the response is returned as text/vnd.turbostream.html. Destroying was easy, right? The first new test checks if we have the correct action path on our form and that it includes all the necessary elements. The next test checks the path in a different way. We send a TurboFrame header and expect the form to be wrapped in a TurboFrame with the correct ID. Then we check localization. In the last test, we assert that Rails sets max age equals 0, private must revalidate, which helps avoid stale form content in the browser. The test for our new action is only one part. We actually have to test the creation of a chat in different ways. But before we create a chat via classic HTML, let's take a quick look at the chats helper I include. It helps us create and update a chat, both via HTML and Turbo, and includes an assertion for chat name errors. These helpers are used in every test. For example, we try to create a chat with invalid params, like an empty name, make sure the chat isn't created, and assert that the correct error messages are shown. The test in line 40 does the same, but for turbo streams. The successful creation is tested implicitly. In the test in line 48, we check that invalid user input, like a chat name with a $sign, is preserved in the form field after the submission fails. Model-level validations are covered in the model tests, and I test the tooltip itself in the system tests. The test for the edit view is similar to what you've already seen, so I'll skip it, which brings us to the tests for updating a chat. And honestly, they're very close to the create tests. Oops, and again, I spotted something while talking through the code. Did you see it too? I use the HTML update chat helper method here without explicitly including the chats helper, even though earlier in the create test I mentioned that I included it. So obvious, but I missed it. Turns out, since I include the chats helper in my test helper.rb, it's already available by default. No need to include it again. Shame on me? Not really. But I know this is one of those moments you can probably relate to. Smiley. And finally, our last controller test, Chats Controller Drawer List Item Test. It's a simple view test and links to the Hotwire Turbo Rails Frame Request Controller Test.rb. Coffee break, at least for me. With a fresh mind, let's quickly jump through factories, tests for the application helper flash methods, and the first integration tests. Let's take a quick look at the user factory. We generate a unique email for each user and set a reusable password and confirmation. I started with password 123456 until I noticed that Chrome, during system tests, was showing this annoying insecure password warning. So I added a hashtag and question mark, fixed it. There's a with 3 chats trait that creates 3 chats after the user is created. And a second variant, user with chats, which sets up the has many association inline. The factory for chats? Super simple. The application helper test.rb file includes the flash helper. Since this isn't part of my global test helpers, I correctly included it just for this test file. The assert flash structure method name is clear enough, and the use of a Nokogiri HTML fragment was the only reliable way I found to assert that the required data attributes are present. Now I can reuse these helpers in the application tests to verify correct CSS classes, structure, and behavior. And with render inline plus Nokogiri, the tests pass. Let's check the full authentication flow. First up, signing in. We post valid credentials, follow the redirect, and assert that the user lands on the dashboard with both the drawer and drop-down buttons visible. Then we test signing out. We log in, log out using the helper, and confirm we're redirected to the login page with the expected flash message. And finally, in the invalid login flow, we test that the redirect and flash message behave as expected when given wrong credentials. By now, you've seen a lot of tests and some helpers. So the flash messages test in shared, nothing new here. I open the integration/chats folder and I start again with the indextest.rb, which is a flow test. Remember? In this index flow test, I use the with3chats trait, log in, and visit the index page. Then I assert that the turbo frame is present and that all 3 chats are rendered with the correct links. Show flow test. Check. New flow test. You've seen this in the controller new test. Check. Create flow test. Same. Check. Destroy flow test. Check. Edit and update flow tests. Check. At a certain point, controller and integration tests start to overlap. I haven't fully figured out how I want to handle that yet, but keep in mind, this project is connected to Candy, where I'm working with AI to create tests. So I don't mind these little duplications. Having consistent patterns makes it easier for an AI to follow the rules. That being said, let's have a look at the model tests. The user test follows the same pattern as my controller tests. It contains high-level or miscellaneous tests for the user model that aren't covered in more specific test files. So I build a user using the factory and assert that it's valid. A simple sanity check, but helpful to catch broken factories early. At the beginning of this video, we took a little detour into the documentation, so the file names in the test models folder should already feel familiar. If we look at the user model itself, you'll see how I like to structure my models. First section, the includes at the top, in this case, the UID concern. Then we define constants, like this email validation regex, which gives us full control over how email addresses are validated. Below that, I've grouped comment sections, attribute macros, normalizers, associations, enums, callbacks, and so on. Even if some sections are empty now, I like keeping the structure consistent. It helps me find things quickly as the model grows. We normalize the email address by stripping whitespace and downcasing it before saving. We use has secure password for authentication and define the associations, chats, and sessions, both with dependent destroy. Validations, self-explanatory. Everything else, like callbacks, scopes, and methods, will be added later, as needed. With this structure in place, it's just a matter of working through each user story. Some of them are kind of silly, like checking for a non-existent company or post association. But hey, this project is for fun. Keep that in mind. We check that the chats association is correct and that the dependent destroy works as expected. The user auth test checks the has secure password setup. The callbacks, role enum, and scope tests are still empty. That leaves us with the user normalization test, which is readable enough, so I'll just keep talking for a bit while you read. And finally, user validations test. I set up a valid and an invalid user. Then I check, for example, whether an empty email throws the correct 2 validation errors. We also test uniqueness and run through a few invalid email addresses to make sure each throws the expected errors. I hope you don't mind if I speed up the rest of the model tests a bit. If I scroll down to the system tests, yeah, you'll see there's a lot more coming. And honestly, I have no idea yet how I'll keep up the momentum to guide you through all of that in detail. So, small steps. Next up, the sanitization concern test. If you want to read it, feel free to check GitHub or just pause the video. The strict validation concern test checks for valid and invalid characters. Chat associations test, check. Chat normalization test, check. Chat validations test, check. Now comes the fun part, system tests. But before that, let's make our developer hearts jump and run all tests. I want to see those green dots. 415 assertions. Awesome. Check. And done. In the application system test case, I include my authentication helper with sign in and visit, and sign out. With the assert alert signed in method, I ensure the UI is fully ready before continuing. And since I'm using Selenium with Chrome, we can actually watch what's happening in the next few minutes. So let's simulate sign in and sign out. Hui, pretty fast. In the sign in, sign out mobile test, I added some delay to make the interactions easier to follow visually. Now, let's head over to the chat system tests. I'll run bash rails test system/chats, so you can see all tests running in Chrome. System tests can be really fun. If a user can click, navigate, and use the app, then the test should do the same. I've split them up into create, destroy, and edit tests, with separate files for keyboard behavior. The chat edit test is the most complex, so let's focus on that one. First, we test the happy path. The user logs in, opens the chat list, clicks edit, enters a new name, and submits it with enter. We check that both the UI and the database update. Next, we try an invalid name, like invalid name. This triggers native HTML5 validation. We assert that the input is invalid and that it has the correct pattern and title attributes. Then we simulate bypassing the HTML5 validation. We strip the validation attributes with JavaScript and submit the form using a name that's still invalid server-side. The model error appears and the field is marked as invalid, just as expected. Finally, we test canceling. The user hits escape, the edit form closes, and the original chat view is restored in place. The remove validation attributes and assert HTML validation attributes methods are only used here, so they stay in this file. The name of Edit with Keyboard Test says it all. We start by navigating to the edit link using Tab, press Enter to open the form, and confirm it renders with the correct input. Then we test a few ways to submit, pressing Enter directly, blurring the field by tabbing away, pressing Tab and Shift Tab. Each one should save the new name and update the UI. Finally, we test escape. We start editing, type a new name, cancel with escape, and the original name is restored. Did you notice line 103 where I use focus element with tab? That's another little helper from Keyboard Navigation Helper. It focuses the element matching a selector by sending tab presses until it's focused. You can also pass a max tabs option to avoid infinite loops. So, system tests for chats. Check. Since chats are managed inside the drawer, let's head over there. These tests use Drawer Helper, which provides utilities like asserting the drawer is hidden before opening it. And these tests are super readable. Let's run them. All pass. Great. Now that this component is solid, we can test how it works inside our dashboard. Starting with the Chat UI test. This one checks the chat list UI inside the drawer. We open the drawer using a helper, make sure it's visible, and wait for the first chat to load. Then we assert the drawer title, check for the new chat form, and verify that the chat list matches expectations. Inside each chat item, we confirm the name, edit link, and delete button are all present. One thing to note, all drawer tests are one test per file. Otherwise, my CI workflow with Headless Chrome fails, due to the dialog element as explained in Part 1. If you're curious, there's a screencast linked in the description. I picked the Chat Edit with Tab test to highlight one nice detail, restoring focus after reopening the drawer. We open the drawer, focus the second chat's edit link, press Enter to start editing, and update the name by pressing Tab. We confirm the name is updated and that the correct chat remains focused. Then we inspect session storage to make sure the focus data was saved properly, both the frame ID and the target element. We close the drawer with Escape, reopen it, and confirm that focus returns exactly where it should, on the same chat's Edit button. All other drawer tests, I'll just quickly open them. They're descriptive, and they all use helpers and assertions we've covered so far. Nothing new to explain there. That leaves us with the 4 flash message tests in Shared Lash. Not that exciting to watch. And the main navigation drop-down test, which runs so fast that I'll slow it down later in Premiere. I think this is it, at least for testing for now. Next up is part 3 of this series, documentation for architecture guidelines, covering controllers, models, stimulus, and testing conventions. So stay tuned. I hope you had some fun with tests. Greetings from Hamburg, Andy.